Okay, so once again, hello everyone, and hope you had a great week. So today we are going to proceed on with the credit card fraud detection project, and I'm going to proceed on from where you left off. And the first part you did was importing the necessary libraries that you needed, ignoring warnings, then importing your dataset. So for me, I have the dataset in here. So in my local machine, so I'm going to import the data directly. Then you went ahead and checked the top 5 rows of the data set, and this is what you have. So we have a time column, we have some v1 to v28 columns. So I don't really know what those columns are for. Then we have the amount and the class column. So I guess the class column is the target column because this is what we will be trying to predict in the end. And then here you print the data info. So we have integer, floats. Yeah, so each and every value we have here is a number. Then you went ahead and checked for missing values. So there are no missing values in the data set. If you check the shape of the dataset, you have 284, 807 values, then 31 rows, and the number of duplicates we have is 1081. So what I can do is I can correct this code. So this is okay for dropping duplicates, but what you can do is you can add in place equals to true instead of creating a new variable, but you can leave it as it is. Then if we check data for duplicates again, we have no duplicates. Then if you check the summary statistics, we get some values there. So I won't go through the summary statistics because we have lots of numeric columns and we can't really go through each and every one of them. Then you went ahead and plotted the distribution of these data sets. So first of all, one thing you need to know is when checking the distribution of a data set, so it's not a must you normalize the data all the time, because the thing is up here when you are defining the problem statement. So for example, what you are trying to predict. So in our case, we were trying to maybe predict if something is a fraudulent transaction or not. So us having a normal distribution will not maybe influence the results that we will get, because if we head over to Google and search, so if we search normalized data and classification, let's see how it affects. So normalizing a data is just to like reduce its size so that it's in a range between 0 and 1. Okay, so that for example, if we had a salary of 100,000, we will reduce it to some smaller values. Okay, so I don't know if it will affect the data results as that much. So let's proceed. But these are some of the things you saw. So for time, yeah, we had this first time here, this second time here. So for time, we have two peaks. So maybe if we standardize this data, we can get a single peak. Then v1 and all the other variables that we have there. So this is the time histogram. So this is what you get. And this is the amount histogram. So for amount, I think we have some outliers which we would like to handle, because you can see most of the amounts that are being transacted are here. And before we proceed, we would like to check these amounts that are above maybe 5,000 and see what kind of transactions do we have there. Okay, so yeah, so that will be my main aim for now. So that will be on the EDA part. Then if we do the count, we have fraudulent 492 fraudulent activities and 2084 315 non-fraudulent activities. So this is their distribution. So the classes are really imbalanced. So we have more non-fraudulent transaction as compared to the fraudulent transaction. So if we were to make a model that is to predict fraudulent transactions, then this model will really struggle to come up with predictions for the fraudulent activities because we have less data points for these events. Then you check the correlation, and I guess that's where you stop. So I'm going to delete this code cell here. And what I'm going to do is we are going to investigate the amount. We are going to investigate the amount column. So first of all, what we are going to do is we are going to get the summary statistics of the amount column. So we're going to have df amount, then describe. So I guess were you using df? I guess you created a different data set here when you removed the duplicates. Yeah, so it should be, let me change this part, then we can proceed. So we are going to have drop duplicates, then in place should be equals to true. I can run that. Then we can check df.duplicated.sum. We have no duplicates. Then df.shift. We have no duplicates. So I've saved that, and that's what we will be using. So let's proceed. So let's continue and investigate our amount column. So this is our amount column. So we have our mean at 88. We have our standard deviation being 250. We have the max value being 25, 691. So what I'm going to do again is I'm going to create a box plot to check for outliers. So I'm going to create a box plot for the amount column. So we are going to say SNS dot box plot. Then we are going to have the class, then we are going to have the amount, then our data is df. So basically this is what we have. So let me type in something else. So sns dot set. This is what we have. So we have class 0 and we have class 1. So you can see for class 0 we have a lot of outliers above the amount 200, because you can see our mean is at 88. Our 75th percentile is at 77. Okay, then our max is at 25, 691. So what else can we do to like group these amount columns? So what I'm going to say is I'm going to group the amounts in groups of 100. Okay, and then we can plot a graph. So we are going to have groups being equal to df.group by, then we cut the amount column, then we arrange it in groups of 100. So yeah, then we can plot the graph. Let's see what we get. So this is what we get. So from 0 to 100, we have all these values. From 100 to 200, we have a few of them. From 200 to 300, we have a few of them. So what I will consider as outliers are these amounts that we have here from maybe, let's say, maybe we can also print out the count. We can print the counts and see. So this is what we have. So maybe I can say anything that we have for maybe, let's say, less than values that are less than 1000. So for values that are less than 100, let's see how they are, because this is a fraud detection thing we are trying to create. So let's use a cutoff point of 1000, for example. So I'm going to say something like df, then I select df, I select amount which are greater than 1000. Then we select the class and do the value counts to see what we have. So here you can see we have 2929 26 non-fraudulent transaction, then 9 fraudulent transaction. Then let's say maybe less than what? So let's say less than 101. Let's see how many transactions we have. So for less than 101, we have 348 fraudulent transaction. Maybe let's say this 2300 here, 2300. So this is just doing some EDA to see like if some of these values that we have here are relevant. So here we only have class 0. So for 2300 and above, class 0, 2200 and above, class 0. Let's say from 1800 again, because I see something here. Okay, so here we have only 2 transactions that are fraudulent. So you see, these are some of the things you need to check when working with these data, because the fraudulent activities that we have are 492. So you need to identify and see where they are starting off from. So 1800. So let's go back to something like 1500. Instead of 1800, let's go to 1900. For 1900, we have one fraudulent activity. Let's go to 2000. We have one fraudulent activity. 2100. One fraudulent activity. 2200. No fraudulent activities. So yeah, we can drop values that are above 2200, because basically we know that any amount that is above 2200 is not considered as a fraudulent activity. Okay, so let's do that. So drop amounts greater than, yes, any questions?
Okay, thank you. So, okay, is it when you categorize, let's say top 1% of the data,
Yeah.
you consider to be outliers. Can it also work based on that too?
When you do what? Like when you check the percentage of the data.
Yes, yes. When you check the percentage, and maybe you categorize like the top 1% or the bottom percentage of that data, if it is is it a good way also to check for outliers through that means?
Yeah, it depends with the task you have at hand. Because you see how I've approached mine. So I'm checking for instances where we have no fraudulent activities and considering those as outliers, not just looking at the box plot. So if you were to talk of maybe the 1% part, I think that can work, but yeah, I'm not sure. I've never used that before to like drop outliers. Yeah. So let's proceed. So let's drop amounts greater than 2200. So DF should be equals to DF. Then we select amount less than 2200. So that's what we have. So if we draw our box plot again, then remove the limits here. This is our box plot. So you can see we have a lot of outliers up here, but there is nothing else we can do in regards to these outliers that we have here, because our main aim is to detect fraud, right? And if we can't use data that is there, because you see here we have only 492 fraudulent activities. So if we drop even one of them, then it means we are maybe doing something wrong, because we won't capture each and every detail we need from these data. So that will be the only part I'll drop outliers. Then I think for outliers, I will only, so if it were me handling this project, I will only work with the amount column to like, yeah, detect fraud or drop outliers, because I know this is the main column when it comes to like determining if a class is fraudulent or non-fraudulent. So if we go here to the correlation part, yeah, we don't have that much correlation between the data sets, which is, yeah, not really bad, because this is not a regression task, so we don't consider correlation that much. Yep. Then another thing we can do is we can normalize the data. So how do we do that? So let's check I won't normalize the amount column because already it's okay the way it is. So there is no need for us normalizing it. So maybe I can use another column example for normalization, and that can be something like the time column. So this is our distribution plot for the time column. Let's go ahead and see how we can normalize this column. But I guess we have these deep here. That we need to check. Okay. So for normalization of data, so I'm going to just show you guys some few things that we do when we normalize data. So here we can use the min max normalization. So what does that do? Let's go ahead and check min max normalization. So min-max normalization, usually called feature scaling, performs a linear transformation of the original data. So this technique gets all the scaled data in a range of 0 to 1. So this is the formula that achieves that. Okay, so we take x mean divided by the x maximum minus the x minimum. So here we can maybe create a function that can do that. So we can have def min max. Then here we can have our df, comma, then call name being equals to this column, this formula here. So you can see we are taking the column name minus the column name minimum. Then we divide by the column name maximum and the column name minimum. So this is the formula that you are seeing here. Okay, so it's not that much complicated. So this is the formula that we are seeing here. So I'm implementing the same formula here. So I have that function created. So what we can do is we can normalize the time column. So here we are going to say min max. Then we pass in our data frame, so df, then time. Then we can run that, hoping we won't get any errors. So then here I can say my data scaled should be equals to that. Then what we can do is we can plot this again. So I can change this to data scale, then run this. Then we can see what happens when we normalize our data. So if we normalize our data, this is what happens. So the plot is still same, but the range is different, because you see here we had 0 to 17,500, and here now we have 0 to 1. So that's what normalization does. So it reduces the scale of your data. So instead of you having huge values, then you are going to have values that are in a smaller scale. Okay, that's basically what normalization does. Yeah. Then another thing you can do is maybe what Tony was trying to do is, okay, so transform maybe your data to be normally distribution to normal distribution. So this is what maybe you are trying to do. So yeah, we need to do some research as to how we can do that. So you can use the np.log1p to normalize your data. So basically that's what we usually use most of the time. So we can try that using the column that we have here. And we are going to say transform time column data to be normally distributed. So we are going to say our data scale, then we are going to say time should be equal to np.log1p. So the reason as to why we usually use log1p is because of, do you see this +1 part here, is for us to eliminate the need for using the +1. Because if you do something like np.log1, you are going to get an error. Okay, so log1, no error. So I think it's log0. So you get an error, negative inf. So we use the log1p so that we can have something like 0 plus 1 instead of just having a 1. So what this does is, for example, if you look at this plot, we only have values ranging from 0 to 1. So once we've scaled our data, we can normalize, we can change it to a normal distribution using this code here. And for us to like eliminate errors that might arise, when creating a normal distribution for these zero values, we use the log 1p. So if we run that, we normalize it. We create a normal distribution for the time column, and if we do the plot again, let's see what we get. So this is what we get. So you can see it's still somehow similar to what you had. So you have those two peaks. So this means that you have two classes of time. So one class is at 0.1 to 0.4, and the other class is at 0.5 to 0.7. So yeah, basically that's what you have. So that's what I'm going to take you through for today only on data scaling and data normalization. So like creating normal distributions for your data set. So the next thing I'm going to do is I'm going to create a base model. So this is a model that you guys are going to work on and improve when creating your machine learning models. And that means that you'll have to explore all these other variables that you have in your data set and see how you can eliminate outliers. So I've already shown you for the amount column how I've eliminated the outliers. So I've checked for amounts. So from which amount do we get no outliers, and I've removed those from the data. So here I'm going to create a base classification model for credit card fraud detection. So I'm going to import libraries. Then I'm going to have from sklearn dot model selection import train test split. Then I'm going to import the conversion matrix and the classification report, because these are the main things we need from these data. Then we are going to have from sklearn. Okay, then I need to add the I think it should be the ROC, AUC score, and the ROC curve. Those are the things we need. Then I think we have a base model in sklearn. So sklearn base model. I think should be the base estimator. So from sklearn dot base import base estimate, or maybe I can use a random forest for our base model. Then we are going to have our x being equals to data scale dot drop. Then we are going to drop the class column. Then our y should be equals to data scale. Then we get the class column. So after doing that, we are going to split the data into train and test set. So we are going to have x train, x test, y train, y test being equal to that. Then our test size, I will use 0.3. So that means that our test size is at 30%. Or maybe we can use 25% as our test size. Okay, so we can run that. Then here I'm going to instantiate the ML model. So here we are going to have RF for random forest being equals to random forest classifier. Then we are going to feed the model to our data. So we are going to have ref.fit x train, then y train. Then we are going to make predictions. So we are going to have our y pred being equals to rf.predict. Then we can have that. So the next thing we can do is we can visualize. We can visualize the conversion matrix. So what we can do here is we can get our conversion matrix, which will be equals to conversion matrix. Then we can print it. So this should be our CM. So the model is still running. So you guys give me a minute. I'll be back as the model is running. Okay. Okay, so I am back. So maybe you can be asking questions as our model is running. So based on what I've shown you so far. Any questions? So I've not scaled some of the columns, but I believe I've shown you how we can do that. We just waiting now to see the results of our base model and see if it's something we can work with and if it's something we can work on improving. So I've done this project before. So this is my output from the project. So it was on the fraud detections, and these were the scores that I got. So the reason as to why I use the random forest model is because here you can see it's got the best precision score. So this is the score that we wanted to see. So maybe I'll share this with you also. Yeah. And this is the ROC curve. So you can see the only model that is going straight up is the random forest. So which has these elbow plot, but here being close to 1 or being close to this corner. So which means random forest performs better as compared to the other models. So, but I guess in this project, we are going to work on trying to like improve the score of this random forest model. So it's taking time to run, but we will be patient. Yeah, you can be asking questions as we are doing this.
Kamole.
Yes. Hello. Hello, Kwamboka.
I have a question. I would like to know because I think it's like your functions
Yeah.
they're inbuilt.
Yeah.
Like you're not typing everything.
Like these codes here.
How did you do that setting?
There are some extensions you need to add to your PC. So for mine, I have some customized that I'm using. And one of them is this one, GitHub Copilot chat. So you can, yeah, here you can see GitHub Copilot. So that's one of them. So if I wanted to like get a code for normalizing a data, I will say something like create a function to scale and normalize a data column. Then I can get my results here. So that's what I'm using. So it's connected to this part here. So it's an extension, so you can add it. Yep. So those are the extensions I'm using, and you will have to be using Visual Studio Code for you to like get access to this. Yeah, so here you can see this is the function I got, and that's the code part. So for me, instead of typing in my questions here, so I just type in comments here and I get the code written for me. Yeah. Is your question answered?
Using the
Yes.
yes, it is. But now for me, I'm not using the Jupyter one. Me, I'm using the Google Colab one.
For Google Colab, there is another extension you can use. I guess I'll have to share that maybe later, but I can check. I can check for you in a minute. Yes, Duncan.
Okay. Also, me question on the feature scaling.
Yes.
I think is it okay also to use maybe dummies when you put a pd dot get dummies yeah on this type of data?
Okay, so for this type of data, we don't have to run the pd.getDummies because, yeah, we have no categorical columns. So we use the pd.getDummies method when we are doing the one hot encoding. And you can see for our data set, it's all numeric. If we go up here, we have no categorical columns, so it's all numeric. So when we are scaling, when we are doing the feature pre-processing, we don't have to run the get dummies method because we have no categorical columns. So categorical columns will be something like this. Let me show you. No, that's not a good example. That's not a good example also. Yeah, a categorical column will be something like this, where we have the cat, ideal, premium, good, EEJI, where we have letters instead of numbers. So that's where we use the get dummies method. So hope that's clear. Yeah, so Brenda, what you can use is this Codium.
Yeah,
Don't know.
yeah, it's clear. Yeah.
Okay. What you can use is this what is called Codium. I don't know why my connection is not working. Just a minute, I check. Yeah, so you can use this, and this can be used on Colab. So what you'll have to do is get the extension. So there is a free version and there is a paid version. So what I'm using here is a paid product, and you'll have to pay 20 USD a month to have access to it. So this wouldn't be ideal for you because you have to pay for it, and we don't have a free version. But for Codium we have a free version. Yeah. Yeah, so that's it. So this is the correlation matrix output. What we need for now is the classification report. So that's the main thing. So I'm going to get the classification report. Then we are going to have our Y test, comma, Y pred. Let's run that and see what we get. So I'll have to type in print for us to see the results in a better way. Yeah, so if we check this, you can see from our classification report, when we are trying to make predictions for non-fraudulent activities, we have an accuracy of 100%. But when we try to make predictions for fraudulent activities, we get an accuracy of 84%. So this basically means that the when you are checking the accuracy of your model, so most of you will go with this, but this is not the way you do it. So what you need to do is you need to get the classification report and see how this model performs in predicting both the positive and the negative classes. So our main interest in this case is predicting the negative classes, which is fraudulent activities. So you can see for fraudulent activities, we have an 84% accuracy because we are looking at the F1 score. And that's what we have. And you can see for this, we have only 120 classes. Yeah. So basically, that's what we have. And I think that should be all for today. So we are going to discuss more next time when we will be trying to fine tune these models and also pre-process these data in a better way. Yeah, so that's all from me for today. Any questions or any inputs from your side? Yes, Duncan.
Okay. Also, just let's say an add-on
Yeah,
on the normalization. Yeah. See,
yes.
also I think it works the same way as the from when you import pre-processing. min max scale. I think it will also work the same way. Yeah.
So when we use from sklearn dot preprocessing import min max scale. Yeah, so it works the same. Yeah. Yeah, thank you for that. So you can use this min-max scalar, or you can create your own functions as I did here. So the results will be same. Yeah. Any other inputs? So I'll stop the recording and I'll upload it